All right, so let's move forward with our quadratic solving. So here are a few examples of completing the square. So before we begin, I just want to solve a few examples of completing the square with you. So whenever I'm solving, I'm isolating the variable. So the first thing that I can do is take the square root of both sides. That leaves me with x plus 5 is equal to the square root of 2. Can subtract 5 from both sides, and x is equal to plus or minus the square root of 2 minus 5. Over here, I'll solve this one as well. So again, I'm isolating this x. I'll subtract 1 from both sides, so x plus 2 squared is equal to 10. I can take the square root of both sides. X plus 2 is equal to the square root of 10, and go ahead and subtract 2. So x is equal to plus or minus the square root of 10 minus 2. So just a few examples. Once we do complete the square and put our functions into this, what we call vertex form of a quadratic, we are able to solve by taking the square root. So up here, when I say the phrase a perfect square, I'm thinking of something like x squared, or, a perfect square where I have x, and on my inside I have x squared. So this right here is a perfect square, and I know that I can expand this, and I can distribute and say this gives me x squared plus 4x plus 4. And over here, this, if I were to factor this would give me x plus 3 squared, which gives me a perfect square. And then I can go ahead and expand, which gives me what I started with, x squared plus 6x plus 9. So looking at these perfect squares up here, what would the last term need to be in order to make this a perfect square? So thinking about what this would look like sort of in that perfect square set of parentheses, this would be x plus 5 squared. Because the only way that I would get this 10 is the same way that I got this 4 right here, or this 6 right here, and it's by adding up this value, this 2 and this 3 together. Because when I expand this x plus 2 quantity squared, I know that I get x squared plus 2x plus 2x plus 4. So it's this 2 and this 2 that end up giving me this 4. So if I were to go ahead and expand this would give me x squared plus 5x plus 5x plus 25. So it looks like in order to make this expression here a perfect square, I would need to add on a 25 in the end. And looking over here, what would I need to add on to this in order to make it a perfect square? This would actually be an x plus 4 all squared, because again, the only way to get this 8 would be to get that 4x plus 4x. And if I were to expand this, x squared plus 4x plus 4x plus 16. So here I have two perfect squares, one in its what we would call sort of nice perfect compact square notation, and the other piece here expanded. So looking down here I have a few examples. I would like to first find the zeros of the following quadratic functions, but I would like to do so by completing the square. So the first thing that I want to do is I want to go ahead and think about what is going to be my piece that goes right here. And that's this second term, but cut in half. So I know that I'll have x plus 2. And I know in my head that x plus 2 really looks like x squared plus 2x plus 2x plus 4. So x squared plus 4x plus 4. And if I look at my original piece up here, I have x squared plus 4x. These two pieces are matching up until their very last term. So I want to think to myself, what will I have to do to this right here in order to make it match my above equation? So right now, as is, this x plus 2 all squared, I have a 4 as my last term here. So what can I do to that 4 in order to make it a 3? I can complete the square and I can subtract 1 from my perfect square. So now I have y is equal to x plus 2 squared minus 1. And I can go ahead and solve this for the zeros now by setting it equal to 0. I can add 1 to both sides. 1 is equal to x plus 2 squared. I can take the square root of both sides, and I'll end up getting that the square root of 1 is equal to x plus 2. Subtract 2 from both sides, and I end up getting 1 minus 2 is equal to x, and negative 1 minus 2 is equal to x. So here, 1 minus 2, this will give me that x is equal to negative 1, and negative 1 minus 2 will give me that x is equal to negative 3. So these are the two zeros or x-intercepts of this function, and we solve that function by completing the square. So let's complete the square for this piece over here and then go ahead and find the zeros of the function. So I have x squared plus 6x minus 2 is equal to 0. And I want to go ahead and x plus 3 is what this would be the start of my perfect square. Sort of off to the side here, I know that this is really x squared plus 6x plus 9. But this 9 is a little bit different than this negative 2. So what would I have to do to 9 in order to get all the way down to negative 2? So here I could subtract 11, and here I could also subtract 11. So now I have my completed square. So x plus 3 squared minus 11 is equal to 0. And I can go ahead and add 11 to both sides to solve. So x plus 3 squared is equal to 11. Take the square root of both sides. X plus 3 is equal to the square root of 11. Subtract 3 from both sides. So x is equal to plus or minus the square root of 11 minus 3. And that would give me my two x-intercepts. And I solved that by completing the square.